becomes hypotheses, which becomes theories, which becomes real. Next slide. This is what we see when we look at it with the liquid chromatograph. This is a little confusing, this slide. I've got 3 different samples overlaid. But those are each of those peaks represents a different cannabinoid. The biggest one is tetrahydrocannabinolic acid. When you burn that, it turns into delta-9 tetrahydrocannabinol, the psychoactive compound. The acid's not psychoactive, but that's the compound that exists in nature. That's the one that all the genetics, the fertilizers, the lighting, the tender loving care of the grower goes into pushing that molecule through the roof. Unfair to the plant, unfair to the medicine. I'd rather see a more balanced profile because it would have a better efficacy. I'm mouthing off a bit, but anyway, look at the red trace there, the top one. You see the big THC acid peak. The peak back from that under the other 2, the blue and the green one, is another red peak. It's much smaller. That's the delta-9 THC. When you heat up cannabis, that big peak turns into the second one because you're blowing CO2 off the THC acid and it becomes delta-9, activated to hit the receptor. With the acid group on, it'll come into the receptor and it won't bind. With the acid group off, it binds to the receptor. So you've got to decarboxylate THC to activate it. Yeah.
The volcano vaporizer, would that be the European model?
I believe it's made in Germany.
Yeah, Germany.
Yeah. Yeah.
Okay.
Oh yeah, I talked about the volcano.
What, $800?
Yeah. You got to have it at setting 7.5 to launch the THC, but it won't go skyward. Before why are you grinning? You're a volcano expert.
Oh, I'm not an expert.
We just love you, Paul. below setting 7 is aromatherapy. No, but don't underestimate aromatherapy. There's a whole medicinal science around that. That's the terpenes. That's the euphoric part of the cannabis. And those are brain molecules too. They're very highly fat soluble. Brain cells are fat, and fat soluble compounds just go right into them and do their thing. Like general anesthesia is the way I look at how the terpenes will work. Similar to alcohol. God bless it. They interact with nerve cells the same way in a general anesthetic-like mode, but the terpenes, I say, are medicinal and very much a part of the cannabis effect and its efficacy. Now, in talking about chronic pain, our members prefer high THC, high CBD, low CBN. CBN is this guy right here. That's CBD right there. They both have acids, but they're not shown here because the blue and the green are decarboxylated. That's THC acid. We've blown it all off here to make delta-9. The members like high THC, high CBD, low CBN because CBN tends to bring anxiety into the mix. CBN is a characteristic of sativas, CBD more characteristic of indicas. Members in chronic pain are searching for indicas. They don't require sativas, are looking for sedation and pain relief, and that comes from the combination of CBD and THC. CBN not really required. How do you translate this into the local cannabis? You have to go with your indicas. In the lower mainland, chronic pain people are using a lot of kushes. Purple kush, organic kush, and a whole slew of kushes. Are kushes known or popular here?
We don't get enough of it.
They're the chronic pain strains. Sadiva's not so much. Good. Next one. Oh, and by the way, our people managing chronic pain are mostly doing oral ingestion of cannabis. Smoking, you'll cycle. You get pain relief here, not here, here, not here, here, not through your day. On an oral prep, you tend to go onto a plateau for 4 to 6 hours. You can smoke in that plateau. You'll go up a blip, but it's not going to affect anything. Most people on oral preps they don't feel the urge to smoke as much. So if you're in severe chronic pain and it's 24/7, I recommend trying oral preps if you have it to manage pain. Different strains, different profiles. Yeah, well, this is the mass spectrum. Mass spectrum right here. On the bottom is an HPLC that I run with a UV detector. It's a glorified UV detector called a diode array detector, but it looks at the whole UV spectrum. Regardless, that's the UV absorption of delta-9 tetrahydrocannabinol, a pure standard that I bought from a company in New Jersey. It's not really delta-9, it's dronabinol. It's synthetic THC that they sell you. They don't sell you an extract from the plant. Regardless, it's calibrated and tested by a number of different spectral photometric methods to ensure that the concentration is 1 milligram per mil of methanol. So if I run this on my instrument, I tell my instrument that a peak with that area is equal to 1 milligram per mil pure THC. Then I run my sample, I see a peak at the same time. If it's the same height, then it's 1 milligram per mil. If it's half that, it's 0.5, double it's 2. Anyway, this is the way we calibrate the instrument to make sure we're identifying and quantifying the peaks correctly. Above it is what I could do if I had a mass spectrometer. You take the spectrum from this peak. Now, if it's running the gas mode, what you do when the molecules are separated on a column, when they come out at the end of the column and hit with high energy electrons, it smashes the molecule. The molecule will always break at its weakest bond, so that there is the fingerprint of delta-9 tetrahydrocannabinol getting hit with high energy electrons at specific settings. You get that sort of fingerprint. You cannot not get that fingerprint if all the atoms are arranged in the molecule in the same way with the same bonds. You'll get, if you do get the same fingerprint, it's the same molecule. If it's not, then it's a different molecule. So you can run that spectrum through a mass spectral library that has every compound that's present in the Merck index, more than 350,000 compounds, and it'll pull up that spectrum and match it to the compound. That way we could go through all